continuous deterioration of metal occur from its surface due to different kinds of chemical and electrochemical reaction of the metal with environment. Do you know what is the phenomena? And I think all of you understand what will be the today's class. Yes, today we'll discuss about the corrosion. Myself, Tanmay Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering. Welcome you all in my first lecture of corrosion. Today we will discuss about the different kinds of corrosion and its corresponding reaction and how we can control this kind of corrosion. So without further delay, let's start the class.
What is the corrosion? First of all, the corrosion is that the continuous deterioration of metal from its surface due to unwanted chemical or electrochemical interaction. So from this definition it is very much clear that there two types of interactions are possible. First one is the chemical and another one is the electrochemical. Okay, so we'll discuss about both types of interaction. Okay, so chemical and electrochemical interaction of metal with its environment. And you know, for example, rusting of iron. This is the common example. I think all of you watch this fact that if any piece of iron will be in open air, then after some days, some months, some years, then you can find out that there will be some rusting. Okay, so this is one type of corrosion. Now, why metals are not found in their free state? First of all, we have to know these things. The metals are thermodynamically unstable in their free state. Okay, they are stable in the form of certain compounds like ore. Okay, so the ore, when we are collect the metal, ores are the thermodynamically stable. But after metallurgy, after collecting the metal from the ore, what happened? They become thermodynamically unstable. Thermodynamically they are unstable. So that's why if it is thermodynamically unstable, this metal always have some tendency to go to the stable state. And what is the way? The way is the corrosion. After corrosion, what product will be produced? This will be not the pure product, pure metal. There some kinds of salts will be there. So these will be the thermodynamically stable product. So this is the very basic principle regarding the corrosion. Okay, that when a metal is in ore, this is the thermodynamically stable product. But when we extract the metal from its ore, it becomes thermodynamically unstable. Then metal has such kind of tendency to go to the stable state by corrosion, because after stable state it produce some kinds of produce some kinds of compounds which will be thermodynamically stable. Okay, thus metal are exist in nature in the form of, in the form of oxides, sulfates, carbonates, which are more thermodynamically stable, okay, than the pure metal. What I told you, in the ore there are different kinds of different forms of the metal you can observe, like oxides, sulfates, carbonates, etc., etc. During metallurgy, the extracted metal have high energy and unstable. Like example, formation of a rust on the surface of the iron. Okay, formation of a green film on the surface of copper. All of you observe these things. The responsible factors for the corrosion of a metal are the metal itself, the environmental chemicals, temperature, and the design also. So this is the main factor regarding the corrosion. That means when we start to learn something, then first of all one question arises in our mind that what is the reason behind this fact. That means why corrosion occurs, isn't it? So this is the reason behind the corrosion. Now come to the point of what are the different types of the corrosion. What are the different types of the corrosion? Mainly there are three types of corrosion. So first one, corrosion in presence of acid. Second one, dry or chemical corrosion. What I told you, this was written in the definition also, isn't it? Chemical and electrochemical. And third one, galvanic or electrochemical, and also this kind of corrosion have another name, that is the wet corrosion. So that these three different kinds of corrosion we have to discuss, we will learn. Okay, so there are different kinds of names also, like it may be we can call it either chemical corrosion or dry corrosion. We can call galvanic corrosion or electrochemical corrosion or wet corrosion. So you should be familiar to each and every name of the type of the corrosion, because otherwise in the exam time you will face difficulty. Because if you know chemical corrosion and the question arises in the form of dry corrosion, it will be very confusing for you. So that's why you should know each and every name for different types of corrosion. Now first of all, corrosion in presence of acid. If you think about the corrosion in presence of acid, then what will be the definition corrosion in presence of acid? First of all, this type of corrosion, you know that this theory suggests that corrosion of a metal means we consider generally the iron, okay, is due to presence of acid surrounding it. According to this theory, iron corroded by atmospheric carbon dioxide, moisture and oxygen. Obviously I will show you the reaction, I will explain the reaction which you are the reaction is reflecting here. I will explain. The corrosion product are the mixture of, this is very important, the corrosion product are the mixture of FeSO3 whole 2, FeOH whole CO3 and FeOH whole 3. The chemical reaction, okay, what is the chemical reaction? This is the chemical reaction. Fe first react with CO2 and H2 and O2, it form FeSO3 whole 2. Then FeSO3 whole 2 plus H2O plus O2, it form FeOH whole CO3 plus CO2 plus H2. Then FeOH whole, that means this again reacts with H2O, that means the moisture, and finally it produces FeOH whole 3 and CO2. So what is requirement here? Look there, oxygen already present in the atmosphere, you know, H2O, you know, moisture, it already present in the atmosphere, and also CO2, this also present. Okay, so in presence of carbon dioxide or moisture and the oxygen, Fe react to form these three compounds, FeSO3 whole 2, FeOH whole CO3 and finally FeOH whole 3. So then come to the point that what is the chemical or dry corrosion. So from the name I think it is very much clear that this type of corrosion on the surface, this type of corrosion on the surface of the metal is taking place in presence of atmospheric gases like oxygen, like halogen, like oxide, like sulfur, like oxides of nitrogen, that means generally it is written as the NOx, okay, oxides of the nitrogen, there may be NO, may be NO2, etc, etc, hydrogen sulfide and the fumes of chemicals with metal. So chemical corrosion, there are so many with so many compounds it is possible, so many gases, atmospheric gases, starting from the oxygen, halogen, oxides of sulfur, oxides of nitrogen, hydrogen sulfide, fumes of chemicals, etc, etc. Then in presence of all these things, metal can corrode. Oxygen is mainly responsible for the corrosion of most of the metallic substances when compared to other gases and chemicals. You know, oxygen, there is a very high amount of oxygen present in the atmosphere. Okay, so and this oxygen is the main culprit for the metallic corrosion. So there are three types of mainly corrosion, that means chemical corrosion. So it is the classification under the chemical corrosion. So first of all, look here that oxidation corrosion. Oxidation corrosion means, from the name it is very much clear, I think, that it will be a reaction with oxygen. So what is the oxidation corrosion? Some of the metals directly react with oxygen in absence of moisture. That means if the air is very, very dry, there is no moisture, even you can expect the corrosion in presence of only oxygen. Alkali and alkaline earth metals react with oxygen at room temperature and form corresponding oxides, while some other metals react with oxygen at higher temperature. Metals like silver, gold, platinum are not oxidized as they are not metals. So according to Wagner's theory, the mechanism of formation of oxide layer on the surface based on the metal, look here. So this is the reaction. First of all, metal, it is converted to the N plus by losing of the n number of electrons, n may be 1, okay, so M plus plus E, whatever. Then oxygen, it will take this electron to form the O minus ion. Then what happened? Then it forms some oxide. So here no requirement of the H2O, isn't it? So look there. So O2 from the atmosphere, there is a metal oxide scale on the metal. During oxidation of a metal, metal oxide form as a thin film on the metallic surface. Okay, so just look at the picture, this picture. Okay, this form a thin film on the metallic surface which protects the metal from further corrosion. This is the another fact. Okay, so when corrosion started at the first stage, the metallic oxide which is formed by the reaction with oxygen, it covers the metallic surface immediately. Then actually after that it protects the remaining part of the metal from the corrosion. If the diffusion or either oxygen or metal is across this layer, further corrosion is possible, otherwise not. Thus, the stability of the layer of metal oxide plays an important role in the process of corrosion. That means if this is the also corrosion, but this thin layer, okay, thin film layer also protect the other part of metal. If diffusion is not possible, if diffusion of either oxygen or metal is across the layer is possible, then the other case, then corrosion is possible. So in this regard, Pilling-Bedworth rule is very, very important. I will discuss what is the Pilling-Bedworth rule. Oxides of lead, aluminium and SN are stable and hence inhibit further corrosion. They form stable, tightly adhering oxide film. So that's why further corrosion will not be possible for these cases. In case of porous oxide film, okay, atmospheric gases pass through the porous and react with metal, and the process of the corrosion continues to occur till the entire metal is converted into oxide. Porous oxide layers is formed by alkali and alkaline earth metals. So this is because of the fact that in case of porous, if the oxide films are not tight, it become porous, then what happens? There may be further chance of the corrosion. Like molybdenum forms a volatile oxide films of MOO3 which accelerate the corrosion. AuAgPt form unstable oxide layer which decomposes soon after the formation, therefore preventing further corrosion. Now come to the most important part. What is the most important part? Peeling Bedworth rule. This is very, very, very important. Okay, you have to understand properly what is the peeling Bedworth rule. So in case of peeling Bedworth rule, specific volume ratio equals to volume of the metal oxide by volume of metal greater than equal to 1. That means if the volume of metal oxide on the surface of the metal is more than the equal to the volume of metal, the oxide layer will protective. For example, Al2O3, CO, etc. So if it is greater than equal to 1 volume of metal oxide, then the volume of metal, it will not corrode further because it will be protective. Otherwise, if it is less than 1, it will not be protective. For example, Fe, for example here, Fe, nickel, tungsten, chromium, it will be non-protective if the volume oxide is less than the volume of metal. Okay, so it is called the peeling Bedworth. Now come to the another part. Okay, so corrosion by the other gases. So that means not only oxygen, there may be chance of the corrosion by the reaction with other gases. Other gases means it may be Cl2, it may be SO2, it may be H2S, it may be NOx. Okay, so in dry atmosphere, instead of oxygen, there may be chance of the reaction with the other gases. For example, or the gases may be protective or non-protective, depends on the its compound. So like dry Cl2 reacts with Ag to form the AgCl, which is the protective layer. That means when Cl2 reacts with silver, what is the silver chloride is formed? It is the protective. But when SnCl4 formed, with the Sn, with the tin, then Sn is volatile. It is not the protective. Okay, another example is that in petroleum industry at high temperature, do you know that H2S attack, even H2S attack the steel to form the FeS layer. Okay, so it is another case that also an FeS scale will be formed. It is the porous. Okay, that means if it is the porous, it will not be protective. Okay, so that means there are several examples are there that with other gases even it may be or may not be protective depending on the situation. Then another example of the corrosion, chemical corrosion, that may be liquid metal corrosion. Okay, in several industries, you know that when molten metal pass through the metallic pipes, okay, it causes the corrosion due to dissolution or due to internal penetration. For example, you know, liquid metal mercury dissolve most metal, okay, metals by forming amalgams hereby. In this way, it corrode the metal. So in this way, actually chemical corrosion also take place. Now come to the different types of corrosion, or the third types of corrosion. This is called the electrochemical theory or electrochemical corrosion or the wet corrosion. Why it is wet corrosion? Because here there is an important requirement of the electrodes. Okay, that means there one cell is produced. Okay, one cell is produced here which acts as the electrochemical cell. So that's why it is called the electrochemical corrosion or the wet corrosion, because water is required. So in this case, actually the chemicals present in the atmosphere or the H2O, that means moisture, it acts as an electrolyte. Okay, so the chemicals and the electrolyte which acts as the acts here, actually it is the electrolyte. Okay, so chemicals plus H2O here, chemicals plus H2O it acts as the electrolyte. It acts as the electrolyte. Then obviously there will be one metal and the another one metal will be anode, another metal will be cathode. Okay, I'll show you one example, then it will be more clear to you what is the electrochemical corrosion or the dry corrosion. The oxidation of anodic part generally takes place. Okay, that means oxidation will be always the anodic part that takes place, and that's why it result the corrosion of the anode. You know this fact very well, that anode there will be corrosion. So that means which acts as an anode, their corrosion occur, and while reduction takes place at the cathode, and this corrosion product is formed on the surface of the metal between anode and cathode. Okay, so now suppose for example of the evolution of the hydrogen and the absorption of the oxygen. So what is the example? So at anode, look here, at anode what happened, Fe, it takes part it takes part in the reaction of the oxidation. Okay, so Fe2 plus 2E, this is the reaction, this is the example of the oxidation. And at cathode what happened, in presence of O2, that H plus E to O2, it produce the H2O, it is the H2O, it produce H2O. Then you know this electron when reacts with H2O in presence of the oxygen, what happened, it produce OH minus, or in absence of O2, H plus E which produce the H2, and electron plus H2O which produce OH minus. So in this way there one anode and one cathode is produced actually. Okay, so here look here, how interesting is it, that anode it automatically become, if you think about the iron, then in iron it automatically it become it acts as an anode, and in cathode there some reaction occur either in presence of oxygen or in the absence of oxygen. Okay, so this is the one example. So obviously the final reaction, what will be the final reaction? So it is the final reaction, Fe2 plus OH minus FeOH whole 2. So this FeOH whole 2, what happened, ferric hydroxide is actually hydrated ferric oxide, that means Fe2O3 H2O, which is yellowish rust. Okay, so which rust we see on the surface of the metal, so this is actually yellowish rust. Anhydrous magnetite Fe3O4, a mixture of FeO and Fe2O3 is also formed, which is brown black in color. It is remarkable that corrosion occurs at anode, but corrosion product is formed near cathode. This is very important, you have to keep in mind that corrosion occur in anode. Obviously anode will be corroded, but corrosion product will be formed near cathode. It is because the rapid diffusion of Fe2 plus as compared to OH, hence corrosion occurs in anode, but rust is deposited at or near cathode. So this is the picture, how beautifully we can explain in this fact that here look here, is the diffusion occur. Okay, it is the acidic solution electrolyte, what I told you, that chemicals present in moisture, it become the electrolyte, and this is the cathodic reaction. Okay, so what happened here, look here, that here in anodic area, this is the anodic area. Okay, this is the anodic area, and this is a small cathodic area. Okay, that means this is where water will be there. That means if there is some place where there you can find this area water. Okay, so a few drops of water, then this portion beautifully acts as a cathode. Okay, and other metallic part acts as an anode, and definitely after some time what happened, anodic portion there corrosion occurs. Okay, so in this way we can explain the galvanic corrosion or the electrochemical corrosion. So this is the another way, or we can explain also in presence of oxygen. So look here, in presence of oxygen what happened. So look here, that aqueous neutral solution of electrolyte, if there is the no acidic solution present, then if there is only H2O present, even there it is possible in this way. Look here, that it is the cathodic part. Okay, it is the cathodic part, and another is the small area anodic part. Here it is the opposite. Okay, the small area and opposite part, and what happened, there H2O, there rust is produced here. Rust means it is the product, actually it is the after corrosion what is produced, it is there we can see here. And in the middle portion, that means the water, aqueous neutral solution, there the cathode is very large. So that means there, if the water is neutral, then cathodic portion is very large. or if it is the acidic solution, then we have to consider that anodic area will be very very large in that case. So these are the differences between if the water is neutral or not. Depending on this factor, we have to consider that which will be anode or which will be cathode, and from the picture it is very much clear. Now come to the point that what are the differences between dry and the wet corrosion. This is very very important question for you, that you have to understand properly that what are the differences between dry and wet corrosion. So if you think about the dry corrosion, look here. First of all, that corrosion occurs in the absence of moisture. This is very very important. Corrosion occur in the absence of moisture. In case of dry corrosion, from the name I think it is very much clear that obviously here corrosion occur in absence of the moisture. But in case of wet corrosion, look here, corrosion occur obviously in presence of conducting medium. Okay, so this is the wet or electrochemical corrosion. In case of dry corrosion, it involves direct attack of chemicals on the metal surface. Okay, so if it is dry, obviously the chemicals attack directly on the metal surface. But in case of a wet corrosion, there will be no such kind of chance. Here it involves formation of electrochemical cell, because in case of the wet corrosion you have to think about that their direct attack of the chemicals will not be there. There at first there will be form an electrochemical cell, then by the reaction of anode and cathode, by the generation of anode and cathode, the corrosion occur in the anode and the product will be formed near cathode. Okay, that means the corrosion product will be formed. Dry corrosion, it is very very slow. The process is very very slow. But in case of wet corrosion, it is rapid. So dry corrosion, it is very very slow process, but wet corrosion or electrochemical corrosion, it is very rapid process. So we have to think about this fact that if there is the slow process is going on, that means it is the obviously the dry corrosion. But if there is then a very fast process, then we have to consider it as the wet corrosion. Corrosion, in case of dry corrosion, corrosion products are produced at the site of the corrosion. Okay, so what is the product which is produced in the corrosion time? That obviously it will be produced in the where it will be produced at the site of the corrosion. Okay, but in case of a wet corrosion, that corrosion occurs at anode, but rust is deposited at cathode or near cathode. Okay, so these all are the differences, and I again repeat, this is very very important for your exam purpose. Okay, this is very important question. What is the difference between dry corrosion and the wet corrosion or the electrochemical corrosion? Okay, so in simple way, dry means without any liquid state, without absence of moisture, and wet means it is the simply, or you have to keep in mind in this way that wet means it is the electrochemical, so that means there must be generation of such kind of electrochemical cell. And another way, dry corrosion means then the attack of the chemicals directly, but not in the case of electrochemical. Dry corrosion is very slow, electrochemical is not slow, and dry corrosion, their corrosion product will be produced at that site where corrosion occur, but it is not applicable for the wet or electrochemical corrosion. So these all the topics you have to read carefully, very carefully, because corrosion is very important chapter, and there are these three types of corrosion which we discussed till now. You have to check properly what are the three types of corrosion and with their specific examples. Okay, there are some specific examples are there. So in this way, like corrosion in presence of acid, what are the reaction, you have to check properly what is the reaction. Then dry corrosion. Then dry corrosion, again there are different types of dry corrosions are there. Okay, so what are the dry corrosion, what are the types of the dry corrosion, and another thing is that what is the peeling Wentworth rule. It is very very important, you have to check properly what is the peeling Wentworth rule. This is very important for your exam purpose. And then next, there is some kinds of different types of dry corrosion. Then electrochemical corrosion. When you think about the electrochemical corrosion, there are electrochemical corrosion also two types, like if the water is the water is present, acidic water or the neutral water, that means in the way of the H2 evolution or the O2 absorption. Okay, then and finally difference between the dry and the wet corrosion. Okay, so thanks for watching this video, and in the next class meet with you in a different topic. Up to this point, just you have to continue your study. Take care. Goodbye.